Assalamu alaikum beautiful people, welcome to the class of chemistry. This is Shehrbano and I'm gonna make you learn the lesson in the most easiest possible way. Before getting into the video, please subscribe to my YouTube channel and press the bell icon for latest updates. So let's begin. The topic which I'm gonna explain to you is reversible reaction and dynamic equilibrium. Before getting into the topic, we need to know some important terminologies. So first we see that what are reactants. Reactants are present at the start of any chemical reaction. Reactants combine together to form products. Now we will see that what are products in a chemical reaction. The products are formed on the completion of any reaction. They are formed by the combination of reactants. Let us see with the help of an example that what are reactants and products. In this chemical equation, you can see that hydrogen and oxygen are the reactants whereas water is the product. This chemical reaction takes place in the presence of platinum catalyst and heat is provided to this reaction. Now we will see that what are irreversible reactions. These are the type of reactions in which products do not recombine to form the reactants. Furthermore, these reactions always lead to the completion. It consists of only one reaction which is known as forward reaction, and these reactions are represented by a single arrowhead. Now we will see that what are reversible reactions. In these type of reactions, the product recombine to form the reactants. These type of reactions never goes to completion. They consist of two reactions, that is forward reaction and reverse reaction, and these are represented by a double arrowhead. Now we will see an example which will reveal more about irreversible and reversible reactions. Here you can see in the diagram that hydrogen gas and iodine gas are present in a closed bottom flask. When they start reacting with each other, they form colorless hydrogen iodide gas. The purple color of iodine gas fades during the formation of hydrogen iodide. Now we will see this chemical reaction with the help of chemical equations. You can see that in forward reaction, hydrogen and iodine gas combine together to form hydrogen iodide. Whereas in backward reaction, the colorless hydrogen iodide decomposes into hydrogen and iodine gas, which is purple in color. The overall reversible reaction is shown in this chemical equation. It is a reversible reaction because it consists of forward and backward reactions. Moving ahead towards another example, which is the formation and decomposition of calcium carbonate. We will see two cases of this reaction. The first reaction takes place in open flasks. In this case, calcium carbonate is heated in an open flask. It decomposes to form calcium oxide and carbon dioxide. Carbon dioxide escapes out and reaction goes to completion. Forward reaction or irreversible reaction takes place in this case, in which calcium carbonate is decomposed into calcium oxide and carbon dioxide. Here is the chemical equation for this reaction. Now we will see the second case in which the reaction takes place in the closed flask. As the system is closed, carbon dioxide formed from the decomposition of calcium carbonate could not be able to escape out of the flask. Hence, it recombined with calcium oxide to form calcium carbonate back. Initially, the reaction goes on, which means forward reaction takes place. After some time, reversible reaction takes place. Hence, calcium carbonate formation begins at this stage. Now we will see what is chemical equilibrium state. It is a point at which concentration of reactants and products do not change with time. Reactants and products are being created at the same rate. and hence the composition of the reaction mixture remains constant. Here is the visual demonstration of chemical equilibrium state. Here you can see the tiny balls are escaping out and then bouncing back to their position. This escaping out and bouncing back of these tiny balls maintain the chemical equilibrium state. There are two types of chemical equilibrium state. The first one is static equilibrium state and the other one is dynamic equilibrium state. During static equilibrium, the reaction ceased to proceed. This happens mostly in the physical phenomena. For example, a building remains standing rather than falling down because all the forces acting on it are balanced. This is an example of static equilibrium. During dynamic equilibrium, reaction do not stop and the rate of forward and reverse reaction becomes equal. The only point we need to remember in dynamic equilibrium state, the rate of forward reaction is equals to the rate of reverse reaction. Both the reactions are equal to each other but opposite in direction. A very important point about dynamic equilibrium is that it is attained before the completion of a reaction. Now we will explain dynamic equilibrium with the help of a graph. This graph shows the formation of hydrogen iodide. In the beginning, the rate of forward reaction is faster than the rate of reverse reaction. As the reaction proceeds, the reactants gradually decreases, and hence the rate of forward reaction slows down. But the rate of reverse reaction increases. The equilibrium will set up and concentration of various species, that is hydrogen, iodine and hydrogen iodide, becomes constant. The chemical equations for these reactions are shown here. The straight line in the graph shows the attainment of dynamic equilibrium. Now we will wind up our lecture with a quick difference between forward reaction and reverse reaction. In forward reactions, the reactants react to form the products. Forward reactions takes place from left to the right side of the reaction. At initial stage, the rate of forward reaction is very fast, but it slows down gradually. In reverse reaction, the products recombine to form the reactants. The reaction proceeds from right to the left side. Here, the rate of reverse reaction is fast, but in the beginning of the reaction, it is negligible. Hence, the reaction speeds up slowly. Thank you so much for watching.